20 days. That is all we have left before 3i Atlas reaches its closest point to Earth, and in those 20 days, everything you thought you knew about this interstellar visitor is about to be shattered. Because what I am about to show you tonight goes far beyond a simple comet passing through our solar system. The trajectory, the timing, the 7 impossible jets firing in directions that defy the laws of physics, the mathematically perfect alignment with Jupiter that has a probability of less than 0.004% of happening by chance. When you stack these anomalies together, a terrifying picture begins to emerge. What if 3i Atlas is not just visiting us? What if December 19th marks the beginning of something we are utterly unprepared for? What if we are watching the opening moves of an invasion and we do not even recognise it for what it is? Stay with me until the very last moment of this documentary, because the evidence I am about to present will fundamentally change how you see the next 3 weeks. Before we dive in, if you find value in these deep explorations of the mysteries unfolding in our skies, take a moment to hit that like button. The perfect storm approaches. There is something deeply unsettling about precision. When you drop a ball, it falls. When you throw a stone into a pond, ripples spread outward. These are the comfortable predictabilities of physics, the reassuring mathematics that govern our universe. But what happens when an object from another star system enters our cosmic neighbourhood and begins exhibiting precision that should not exist? What happens when the numbers stop making sense unless you consider the unthinkable? 3i Atlas is now less than 3 weeks from its closest approach to Earth, and I need you to understand something that the mainstream coverage is glossing over. On December 19th, this interstellar visitor will pass within approximately 270 million kilometres of our planet. That sounds like a comfortable distance, does it not? Nearly twice the distance from Earth to the Sun. Safe, remote, nothing to worry about. But here is what that framing conveniently ignores. The distance is not the anomaly. The timing is. Think about this for a moment. 3i Atlas was discovered on July 1st of this year by the Atlas telescope in Chile. It came screaming into our solar system from the direction of the galactic centre, a region so densely packed with stars that detecting incoming objects is extraordinarily difficult. It arrived along a trajectory tilted just 5 degrees from the ecliptic plane, the flat disk where all our planets orbit. The probability of a random interstellar object achieving that alignment by pure chance is approximately 0.2%, 1 in 500. Now layer on the timing. 3i Atlas reached perihelion, its closest approach to the Sun, on October the 29th. And where was Earth during this critical moment when the object would be at its brightest, its most active, its most observable? Earth was on the exact opposite side of the Sun. We could not see it. Our ground-based telescopes were blind. Our space telescopes faced geometric constraints that limited observation windows. For weeks during the most scientifically valuable period of its journey, 3i Atlas operated in a shadow of our perception. Coincidence, you might say. Orbital mechanics are what they are. Objects do not choose when to arrive, but the coincidences keep stacking. Before perihelion, 3i Atlas passed within 28 million kilometres of Mars on October 3rd. It came close enough to Venus that trajectory calculations show a passage within tens of millions of kilometres. And now, after swinging around the Sun, it is heading toward a rendezvous with Jupiter in March of 2026 that defies statistical explanation. I want you to hold that thought about Jupiter, because we will explore it in devastating detail later. For now, understand that Harvard astrophysicist Avi Loeb calculated the probability of 3i Atlas arriving at the precise time needed to achieve close approaches to Mars, Venus and Jupiter, while remaining hidden from Earth during perihelion. The odds came out to 0.005%, 1 in 20,000. When you multiply low probability events together, you do not get comfort, you get questions. Let me paint you a picture that might help crystallize what we're dealing with. Imagine you are a security guard at a museum. One night, you notice a shadow move past the east wing at exactly the moment the security camera on that side experiences a brief malfunction. Strange, but these things happen. The next night, a different shadow passes the west wing during another camera glitch. Still coincidental, perhaps. But on the third night, fourth night, fifth night, patterns emerge that are too precise to dismiss. The shadows always move during blind spots. They always pass near the most valuable exhibits. They never trigger alarms because they seem to know exactly where the sensors are. At what point does coincidence become design? 3i Atlas is moving through our solar system with the precision of something that knows where the cameras are. The scientific establishment will tell you that all of this can be explained by natural processes. They will invoke outgassing, the release of volatile compounds as cometary ice sublimates near the Sun. They will point to gravitational dynamics, the predictable ballet of orbital mechanics. And in isolation, each explanation sounds reasonable. Comets do outgas. Trajectories are shaped by gravity. Objects arrive when they arrive. But 3i Atlas is not behaving like any comet we have ever seen. When it passed perihelion, observations from Mars orbiters and solar observatories detected something unprecedented. Instead of developing the expected, massive tail of gas and dust being blown away from the Sun by solar radiation pressure, 3i Atlas emerged with at least 7 distinct jets firing in multiple directions. Some of these jets point toward the Sun, creating what astronomers call anti-tail structures. Now, anti-tails can occur in normal comets under specific geometric conditions, when Earth crosses through a comet's orbital plane and dust particles create an optical illusion. But the anti-tails on 3i Atlas have been confirmed through multiple observations across different viewing geometries. They are not illusions, they are real physical phenomena. And here is where it gets truly strange. These jets extend for hundreds of thousands of kilometres. One structure captured in early November stretched nearly 3 million kilometres into space. At the expected thermal speeds of sublimating cometary material, around 400 metres per second, it would take roughly a month for ejected particles to travel 1 million kilometres. During that time, the rotation of a natural comet should smear and disperse any jet structure. 3i Atlas rotates with a period of approximately 16 hours. Any jets should appear as diffuse, rotating spirals. Instead, the images show tightly collimated streams, precise, directed, almost engineered in their appearance. On November 8th, astronomers captured images showing this complex structure with a glowing halo extending 500,000 kilometres around the nucleus. The jets maintained their orientation despite the rotation that should have scattered them. It is as if they are being actively stabilised, continuously directed rather than passively expelled. I am not telling you this is an alien spacecraft. What I am telling you is that the natural explanations require us to accept a growing list of improbabilities. And at some point, the improbable begins to feel like something else entirely. Consider the mass calculations. NASA's Jet Propulsion Laboratory confirmed that 3i Atlas exhibited non-gravitational acceleration during its perihelion passage. This means something was pushing on the object beyond what gravity alone could account for. For a natural comet, this push comes from outgassing, the rocket effect of material being ejected from the surface. Simple physics, action and reaction. But here is the problem. To generate the observed acceleration, calculations suggest 3i Atlas would need to have ejected more than 10% of its total mass, possibly as much as 50 billion tons of material over the perihelion period. That is an almost incomprehensible amount of mass loss. For context, the minimum estimated mass of 3i Atlas is around 33 billion tons. We are talking about an object supposedly hemorrhaging more material than it likely contains. Where is all that mass going? Where is the massive debris cloud that should be visible to every telescope on Earth? The expected signature of such catastrophic outgassing would be unmistakable, a vast expanding shell of gas and dust that would dwarf the nucleus itself. Instead, observations from November show a relatively compact object. Active, yes. Surrounded by jets and a bright coma, certainly. But not the shattered, disintegrating remnant you would expect from something that just lost half its body weight. The math does not add up. Unless the acceleration came from something other than sublimating ice. I want to be clear about what mainstream science says about all of this. NASA officials have repeatedly stated that 3i Atlas looks and behaves like a comet. They point to the presence of a coma, the detection of carbon dioxide emissions, the overall morphology consistent with icy bodies from the outer reaches of stellar systems, and they are not wrong. 3i Atlas does exhibit cometary features. But here is the thing about disguises. The best ones are not about looking different. They're about looking exactly like what you are pretending to be. If an intelligence wanted to send something into another civilization's star system, something that could observe, catalogue, and perhaps deploy, what would be the optimal camouflage? You would want it to look natural. You would want it to behave in ways that could be explained by known phenomena. You would want the scientific establishment to have ready-made categories to file it under so that no one looks too closely. You would want it to look exactly like a comet. This is not wild speculation. This is the conclusion of a peer-reviewed analysis exploring what a hostile or even merely curious extraterrestrial probe might look like. The paper, co-authored by Avi Loeb and colleagues, specifically examined 3I Atlas in the context of what they called the dark forest hypothesis, the idea that intelligent civilizations in our galaxy remain silent and hidden because the cosmos is a dangerous place. In such a universe, you do not announce yourself. You do not broadcast. You observe quietly and strike only when necessary. A probe designed under these principles would not arrive with flashing lights and radio signals. It would arrive looking like a rock, or better yet, looking like a comet, something our astronomers would dismiss as natural and unremarkable. December 19th is 20 days away. In 3 weeks, 3I Atlas will be closer to Earth than at any other point in its journey through our solar system, and then it will continue outward, toward Jupiter, toward a rendezvous that might be the most significant event in human history. But I'm getting ahead of myself, because before we can understand what might happen at Jupiter, we need to examine the 7 jets that emerged after perihelion. We need to understand why their structure, their orientation, and their very existence challenges everything we thought we knew about cometary physics. And we need to confront a possibility that most scientists refuse to even consider. Those jets might not be exhaust from sublimating ice. They might be something else entirely, something that changes the stakes of everything unfolding in our skies right now. But before we examine the jets themselves, I need you to sit with something uncomfortable. A thought experiment that strips away our assumptions about how first contact or first conflict might actually unfold. We have been conditioned by decades of science fiction to imagine alien arrival as an event, ships descending through clouds, radio transmissions we can decode, a moment of revelation where the universe suddenly, unmistakably announces that we are not alone. Independence Day, contact, arrival. The narratives always feature a clear before and after, a moment where humanity collectively knows. But what if that is not how it works? What if the most dangerous form of contact is the kind you never recognize as contact at all? Think about how we study animals in the wild. The best wildlife researchers do not announce themselves. They use camouflage. They employ remote cameras. They observe from distances where their presence remains undetected. The animals continue their natural behaviours, completely unaware they are being watched, catalogued, analysed. The researchers learn everything they need to know without ever revealing themselves. Now extend that logic across interstellar distances. A civilization capable of sending objects between stars possesses technology so advanced that our entire scientific infrastructure might look to them like campfires look to us. Primitive, predictable, easily monitored without detection. If you wanted to study such a civilization, you would not land on their planet and say hello. You would send something quiet, something that blends in, something that could pass through their entire detection network while they congratulate themselves on having discovered a natural phenomenon. Something like a comet. The perfect storm approaching Earth right now is not just a celestial object on an unusual trajectory. It might be a test of our observation capabilities, a test of how we respond to anomalies, a test of whether we can recognize a hunter when it is already inside the fence, wearing wool and walking among the sheep. December 19th approaches, 20 days until closest approach, and every hour that passes is an hour of observation, an hour of data collection, an hour where something out there might be learning exactly what it needs to know about us. The question is not whether 3I Atlas is watching. The question is, what happens when it finishes watching? And for that answer, we need to look at what emerged from behind the sun when no one on Earth could see what was really happening. The 7 jets that changed everything. When 3I Atlas emerged from behind the sun in early November, astronomers around the world trained their instruments on what they expected would be a relatively straightforward observation. A comet heated by its close passage to our star, releasing gas and dust in predictable patterns. The textbook behaviour of an icy body responding to solar radiation. What they captured instead sent shockwaves through the scientific community that are still reverberating today. On November 8th, a team of astronomers including Michael Jaeger, Gerald Riemann and Enrico Prosperi captured a series of images that should not exist. Using stacked exposures through green, red and blue filters, they revealed a structure around 3I Atlas that defied conventional cometary physics. At least 7 distinct jets emanated from the nucleus, spreading outward in multiple directions like the spokes of some cosmic wheel. Some pointed away from the sun, as expected, but others pointed directly toward it, creating anti-tail structures that persisted across multiple observations and viewing geometries. Let me explain why this matters so much. When a comet approaches the sun, its ices begin to sublimate, transitioning directly from solid to gas. This outgassing creates pressure on the nucleus, and the expelled material gets pushed away from the sun by solar radiation pressure and the solar wind. The result is the classic cometary tail, always pointing away from our star regardless of which direction the comet itself is travelling. This is physics so fundamental that we teach it to children. The sun pushes, the tail points away. Simple. Anti-tails can occur under specific circumstances. When Earth passes through the orbital plane of a comet, dust particles spread along the comet's path can create an optical illusion of material pointing sunward. But these geometric anti-tails are exactly that, illusions created by our viewing angle. Change the geometry, and they disappear. The anti-tails on 3I Atlas do not disappear. They have been observed consistently across different dates, different viewing angles, different instruments. On November 8th, November 9th, November 11th, November 16th, November 17th. Each observation confirms the same impossible structure, jets pointing toward the sun that should not be there. Think about what this means physically. For material to travel toward the sun against the solar wind requires energy. It requires thrust. The solar wind at the location of 3I Atlas flows outward at approximately 400 kilometers per second. Any particles ejected from a natural comet would be immediately swept back by this relentless pressure. To penetrate against it, to push sunward for distances of nearly 1 million kilometers, as observed in the November images, requires outflow velocities and mass densities that strain the limits of cometary physics. Avi Loeb calculated the implications. For the anti-tail jets to extend as far as they do, their ram pressure must exceed that of the solar wind out to distances of roughly 1 million kilometers from the nucleus. Given the 1,000-fold difference between solar wind speeds and typical cometary outgassing velocities, this means the mass density in those jets must be approximately 1 million times greater than the solar wind itself at their outermost extent. Run those numbers through, and you arrive at a mass flux of roughly 2 million kilograms per second across an area of about 1 million square kilometers. Sum it up, and you get a mass loss rate of approximately 50 billion tons per month. That is not a typo. 50 billion tons every single month. For context, the minimum estimated mass of 3I Atlas, based on its lack of non-gravitational acceleration prior to perihelion, is approximately 33 billion tons. We are being asked to believe that this object ejected more than its entire estimated mass in the weeks surrounding its closest solar approach, and yet images from November show a nucleus that remains largely intact. Bright, active, but not the shattered remnant you would expect from something that just lost 150% of itself. Where did all that mass go? This is not a rhetorical question. This is a fundamental problem with the natural comet explanation that no one has adequately addressed. The mainstream response has been to adjust the models. Perhaps our estimates of the nucleus mass were wrong. Perhaps the outgassing is more efficient than we assumed. Perhaps there are exotic ice compositions that behave differently than water or carbon dioxide. Each adjustment patches one hole while opening others. The explanations become increasingly elaborate, increasingly dependent on assumptions we cannot verify. There is another possibility, one that Loeb and others have raised with appropriate scientific caution. What if the jets are not produced by sublimating ice at all? What if they are produced by something else entirely? Consider the characteristics of technological propulsion. Chemical rockets produce exhaust velocities of 3 to 5 kilometers per second. Ion thrusters achieve exhaust velocities of 20 to 50 kilometers per second. Both are dramatically higher than the 400 meters per second typical of cometary outgassing. Higher exhaust velocity means you need less mass to produce the same momentum change. The relationship is squared, so a tenfold increase in exhaust velocity reduces the required mass by a factor of 100. If 3I Atlas were equipped with propulsion systems operating at even modest technological specifications, the observed non-gravitational acceleration could be achieved with less than 1% of the mass loss required for natural outgassing. The jets could appear precisely as they do, directed and sustained, while consuming only a fraction of the object's total mass. I'm not claiming this is what is happening. I'm pointing out that the technological explanation actually requires fewer extraordinary assumptions than the natural one. That should give us pause. But there is another aspect of these jets that demands attention: their orientation. 3I Atlas rotates with a period of approximately 16 hours. This was established through careful photometric observations in July and August, tracking the periodic brightening and dimming as different faces of the nucleus rotated into sunlight. A 16-hour rotation period is not unusual for a cometary body. What is unusual is what that rotation should do to any jets emanating from the surface. Picture a garden sprinkler. As it rotates, the water stream traces out a spiral pattern. The faster the rotation, the tighter the spiral. The slower the ejected material moves, the more pronounced the spiraling becomes. For a comet rotating every 16 hours and ejecting material at 400 meters per second, any jets should appear as broad, diffuse spirals. The material expelled 12 hours ago should be nearly 90 degrees offset from material expelled now. Over the million-kilometre distances observed in the November images, the jets should be smeared into near invisibility. Instead, we see tight collimation, narrow streams maintaining their directional integrity over distances that represent weeks of travel time. The images from Frank Niebling and Michael Buckner on November 9th show jets extending nearly 3 million kilometres with structural coherence that should be impossible for a rotating, passively outgassing body. How do you maintain jet directionality against rotation? You need active stabilisation. You need continuous correction. You need something that keeps the thrust pointed in a specific direction, regardless of how the main body is oriented. Natural comets do not have stabilisation systems. Spacecraft do. I want to share something that struck me as I reviewed the available imagery. In many of the post-perihelion photographs, there is a particular quality to the jet structures that is hard to articulate but impossible to ignore. They look intentional, not in some mystical or unscientific sense, but in the practical engineering sense of systems designed to accomplish specific objectives. The anti-tail jets stop at distances that correspond to force equilibrium with the solar wind. The tail jets extend along precise vectors. The overall configuration has a symmetry and purposefulness that feels manufactured rather than emergent. I realise this is subjective. I realise that human pattern recognition is notoriously unreliable, prone to seeing faces in clouds and intentions in randomness. But I also know that human pattern recognition evolved precisely because patterns often do indicate agency. Our ancestors who dismissed the rustling in the grass as mere wind sometimes became lunch. The ones who paid attention to anomalies survived. We are seeing anomalies, lots of them, and dismissing them reflexively is no more scientific than accepting them uncritically. The coming weeks will provide more data. 3I Atlas is approaching its closest point to Earth, and every major telescope on the planet is preparing for intensive observation campaigns. The James Webb Space Telescope will measure the spectral signatures of the jets, potentially revealing their composition and velocity structure. Ground-based observatories will track the morphological evolution day by day. We will learn more in December than we learned in all the months since discovery. But here is what troubles me. By the time we have conclusive answers about the jets, 3I Atlas will be on its way to Jupiter. It will be leaving the inner solar system, carrying whatever secrets it holds into the outer darkness. If those jets are indeed technological, if they represent some form of propulsion or deployment system, we will have watched it operate right in front of us and done nothing but take pictures. The window for action, if action were ever possible, is closing. 20 days until closest approach to Earth. Then outward, toward the gas giant, toward a rendezvous in March that might be the most significant astronomical event in human history. Because what 3I Atlas does at Jupiter could determine whether we are dealing with a passive observer or something far more active. Something that came here not just to watch, but to do, to deploy, to seed our solar system with technology we cannot yet imagine and might never detect until it is far too late. The 7 jets changed everything because they showed us that 3i Atlas is not behaving like a comet should. But Jupiter will show us what 3i Atlas actually is, and the numbers surrounding that encounter are so improbable, so precisely aligned, that when I first saw them I had to check the calculations 3 times before I believed what I was seeing. The coincidence waiting at Jupiter is not just unlikely, it is almost impossible, unless it was planned that way from the beginning. The Jupiter Rendezvous, seeding the solar system. In all of science, there are moments when coincidence becomes so improbable that it demands explanation. Moments when the numbers align with such precision that randomness fails as an adequate hypothesis. What I am about to share with you represents one of those moments. A mathematical alignment so extraordinary that it has forced even skeptical astronomers to pause and consider possibilities they would normally dismiss out of hand. On March 16, 2026, 3i Atlas will reach its closest approach to Jupiter. This point, called perigove, represents the minimum distance between the interstellar visitor and the largest planet in our solar system. Based on trajectory calculations from NASA's Jet Propulsion Laboratory, incorporating data from over 230 observatories worldwide and accounting for the non-gravitational acceleration observed during perihelion, that minimum distance has been calculated to extraordinary precision. The number is 53.445 million kilometres, with an uncertainty of plus or minus 0.06 million kilometres. Now let me tell you about Jupiter's Hill radius. This is a fundamental concept in orbital mechanics, representing the boundary of a planet's gravitational dominance. Inside the Hill radius, Jupiter's gravity overpowers the tidal forces from the Sun, allowing objects to remain in stable orbit around the planet. Outside this radius, the Sun's gravity tears satellites away, preventing long-term orbital capture. The Hill radius is calculated using a simple formula involving the planet's mass, the Sun's mass, and the distance between them. On March 16, 2026, Jupiter's Hill radius will be 53.502 million kilometres. Read those numbers again. The closest approach distance of 3i Atlas to Jupiter is 53.445 million kilometres. Jupiter's Hill radius at that moment is 53.502 million kilometres. The difference between them is 0.057 million kilometres, approximately 57,000 kilometres. This falls within the measurement uncertainty of just 60,000 kilometres. 3i Atlas will arrive at Jupiter's doorstep with a precision that matches the planet's gravitational boundary to within 1 part in 1,000. Across the vast diameter of Jupiter's orbit around the Sun, this represents an accuracy of 1 part in 26,000. The probability of this happening by random chance, calculated by Avi Loeb using conservative assumptions about the possible trajectories of interstellar objects, is less than 0.004%, roughly 1 in 25,000. Think about that for a moment. Let it settle into your understanding. An object arrives from interstellar space, exhibits non-gravitational acceleration near our Sun, and emerges on a trajectory that will bring it to the precise edge of Jupiter's gravitational sphere of influence. Not inside, where it might be captured, not far outside, where it would simply fly past, but right at the boundary, the mathematical sweet spot where objects can be deployed into stable orbits with minimal energy expenditure. This is not where random comets go. This is where you would aim if you wanted to leave something behind. The Hill radius boundary has special significance in astrodynamics. At this distance, 2 points of particular importance exist, the Lagrange points L1 and L2. These are positions where the gravitational forces from Jupiter and the Sun, combined with the orbital dynamics, create zones of relative stability. Objects placed at Lagrange points require minimal fuel for station keeping. They can maintain their positions indefinitely, with only occasional small corrections. Every spacefaring civilization on Earth uses Lagrange points for exactly this reason. The James Webb Space Telescope orbits the Sun-Earth L2 point. Various solar observatories occupy L1. These are the natural parking spots of celestial mechanics, the places where you put things you want to stay put. If 3i Atlas is a natural comet, its arrival at Jupiter's Hill radius is an almost miraculous coincidence. But if 3i Atlas has agency, if it is guided by some form of intelligence or programming, then the Hill radius is exactly where you would want to be for one specific purpose: deployment. The scenario Loeb outlines is haunting in its logic. Suppose 3I Atlas is a mothership, using cometary camouflage to traverse interstellar space and enter target solar systems undetected. Suppose its mission is to seed those systems with technological devices, observation platforms, communication relays, or other apparatus we cannot even imagine. Where would such a mothership deposit its cargo? Not near the inner planets, where detection risk is highest and orbital dynamics are complex. Not in the outer reaches, where distance limits utility. Jupiter represents the optimal middle ground, massive enough to anchor stable orbits, far enough from Earth to avoid easy detection, central enough to observe the entire inner solar system, and the Hill radius specifically is where you would release your payload if you wanted it to remain in Jovian orbit without the Sun eventually stripping it away. Any satellites deposited outside this boundary would be lost. Any deposited inside would be captured but might require additional manoeuvring to achieve stable configurations. Right at the edge is perfect. The non-gravitational acceleration that 3I Atlas exhibited near perihelion takes on new significance in this context. Without that acceleration, where would 3I Atlas have gone? Trajectory calculations without the perihelion boost show a slightly different path, one that would have passed Jupiter at a greater distance. The acceleration was precisely what was needed to shift the trajectory from a near miss to a perfect approach. It was, in effect, a course correction, a small adjustment that turned an unremarkable flyby into something potentially extraordinary. I want to be careful here. I am not telling you that 3I Atlas is definitely an alien mothership about to seed Jupiter with technological probes. I am telling you that if it were, the trajectory we are observing is exactly what we would expect to see. The math fits, the timing fits, the precision fits, and here is what makes this so maddening. We have no way to verify what happens at Jupiter in March. The distances involved are immense. Earth-based telescopes will see 3I Atlas as little more than a point of light at that range. We have spacecraft in the Jovian system, notably NASA's Juno mission, but Juno was not designed to detect small objects being released from a passing comet. Its instruments are optimized for studying Jupiter itself, not cataloguing potential artificial satellites appearing in high orbits. ESA's Jupiter Icy Moons Explorer, known as JUICE, is currently en route to Jupiter but will not arrive until the early 2030s. By then, any devices deployed by 3I Atlas could have dispersed, gone dormant, or taken up positions we would never think to look. We might be witnessing the most significant astronomical event in human history, and we lack the tools to properly observe it. This is the cruelty of cosmic timescales and the limitations of our current capabilities. We see enough to suspect, but not enough to confirm. We have data that raises questions, but not data that answers them. We are like witnesses to a crime scene who arrived moments too late, finding only circumstantial evidence and footprints that lead into darkness. What would deployed devices even look like? This is where imagination must fill the gaps left by our ignorance. They could be passive observers, simply watching and recording over decades or centuries. They could be communication relays, nodes in some vast interstellar network that we cannot detect because we do not know what frequencies to monitor. They could be manufacturing platforms, using Jovian resources to construct additional devices in a process of exponential self-replication. Or they could be weapons, dormant capabilities waiting for a trigger we cannot anticipate. I do not say this to frighten you. I say it because intellectual honesty requires acknowledging the full range of possibilities. If an intelligence sent 3I Atlas to our solar system, we have no way of knowing its intentions. The same precision that would enable careful scientific observation would also enable strategic positioning for less benign purposes. The same camouflage that allows undetected entry would also allow undetected deployment. We simply do not know, and that uncertainty is perhaps the most unsettling aspect of this entire situation. The next few months will provide fragments of additional information. As 3I Atlas recedes from Earth toward Jupiter, its brightness will fade, but careful observation might reveal changes in its behavior. Any significant releases of material could potentially be detected as variations in the object's light curve or trajectory. The Juno spacecraft will be alerted to watch for anomalies in Jupiter's vicinity. But I suspect we will learn nothing definitive. The distances are too great, our instruments too limited, our window too brief. 3I Atlas will arrive at Jupiter's Hill radius, do whatever it is going to do, and continue outward into interstellar space, and we will be left wondering whether we just witnessed a cosmic coincidence or something far more profound. There is one more piece to this puzzle that deserves attention: the timing. Why now? Why 2025 and 2026? Interstellar objects pass through our solar system constantly. Models suggest there may be one or more inside Saturn's orbit at any given time. Most go undetected because they are small, dark, and travelling against the crowded background of the Milky Way's stellar disk. 3I Atlas stood out because of its size, its brightness, and the fortunate angle of its approach. But if it is artificial, the timing might not be coincidental at all. We are at a peculiar moment in human history. Our detection capabilities have recently advanced dramatically. The Atlas telescope network that discovered 3I Atlas only became fully operational in recent years. The Vera Rubin Observatory, which will transform our ability to detect interstellar objects, is just coming online. A civilization that has been watching us, that has been waiting for us to reach a certain level of technological sophistication, might choose exactly this moment to send something. Not so early that we would miss it entirely. Not so late that we might be capable of meaningful response, but right at the threshold where we can see enough to wonder but not enough to act. If that is the case, 3I Atlas is not just a visitor. It is a message, a test, perhaps even an invitation, though to what remains horrifyingly unclear. The Jupiter rendezvous approaches. In less than 4 months, the most mathematically improbable encounter in recorded astronomical history will occur at the edge of our solar system's largest gravity well. Whatever happens, there will happen beyond our ability to observe clearly, beyond our ability to influence, beyond our ability to do anything but watch and wait and wonder. But before Jupiter, there is December 19th. Before the outer system rendezvous, there is the closest approach to Earth. And before we can understand what might be waiting for us at Jupiter, we need to understand what 3I Atlas did during those crucial weeks when it was hidden behind the Sun, executing manoeuvres in the one place where no human eyes could follow. The hidden perihelion manoeuvre. There is a concept in military strategy called the blind spot attack. You do not strike where your enemy is watching. You do not move when they expect movement. You wait for the moment when attention is elsewhere, when sensors are compromised, when the geometry of observation creates a natural shadow. Then you act, quickly and decisively before the window closes. 3I Atlas arrived at perihelion on October 29th, 2025. Its closest approach to the Sun occurred at a distance of approximately 203 million kilometres, just inside the orbit of Mars. This was the moment of maximum solar heating, maximum activity, maximum scientific interest, and it happened when Earth was on the exact opposite side of the Sun. From our perspective, 3I Atlas was in solar conjunction. The Sun's overwhelming glare made ground-based observation impossible. Space telescopes faced geometric constraints that limited their viewing windows to brief, suboptimal opportunities. For weeks during the most critical phase of its journey, the interstellar visitor operated in effective darkness, shielded from human eyes by the very star we orbit. Coincidence, orbital mechanics, the cold equations of celestial motion producing an unfortunate alignment, or perfect timing for something that did not want to be watched. Let me walk you through the chronology. 3I Atlas was discovered on July 1st. Through July, August and September, it was observable from Earth, and hundreds of observatories tracked its motion. During this period, careful analysis revealed something peculiar. Despite approaching the Sun and warming significantly, 3I Atlas showed minimal non-gravitational acceleration. For a comet actively outgassing, this was unexpected. The released gases should produce a measurable thrust, a detectable deviation from purely gravitational motion. The lack of this deviation allowed astronomers to estimate a minimum mass for the object. If it was a low-mass comet, even small amounts of outgassing would produce noticeable acceleration. The observed stability implied either very low activity or very high mass. Calculations suggested a minimum of 33 billion tons, corresponding to a nucleus diameter of at least 5 kilometres. Then came October. As 3I Atlas approached perihelion and slipped behind the Sun's glare, Earth-based observations ceased. But Mars was positioned favourably. NASA's Mars Reconnaissance Orbiter, the Mars Express spacecraft, and ESA's ExoMars Trace Gas Orbiter all captured images of the visitor during this critical window. These observations were invaluable but limited, constrained by the instruments available and the distances involved. What they showed was an object brightening dramatically as it neared the Sun. This was expected. More sunlight means more heating, means more sublimation, means a brighter coma. Standard cometary behaviour. What the observations could not show was detailed structural information. The resolution from Mars orbit was insufficient to reveal jet configurations, morphological changes, or any discrete events occurring near the nucleus. 3I Atlas was a bright smudge against the stars, active and luminous, but fundamentally unresolved. When the object emerged from solar conjunction in early November, everything had changed. The 7 jets, the complex anti-tail structures, the collimated streams extending millions of kilometres, the non-gravitational acceleration now clearly detectable in the trajectory data. Whatever happened during those hidden weeks around perihelion transformed 3I Atlas from an unusual but explicable comet into something that defies easy categorization. Here is what we know about the physics of perihelion passages. The intense solar heating causes ices to sublimate rapidly, releasing gas and dust that forms the coma and tail. Surface features can change as volatile-rich regions exhaust themselves and new areas become active. Comets have been observed to fragment, to brighten unexpectedly, to develop new jet structures as different parts of the nucleus respond to thermal stress. All of this is natural, all of this is documented, and none of it fully explains what we are seeing with 3I Atlas. The non-gravitational acceleration poses a particular puzzle. NASA's Jet Propulsion Laboratory has been updating their models as new data comes in. In late October, the radial acceleration component was estimated at approximately 1.6 times 10 to the -6 astronomical units per day squared. By late November, revised models using different assumptions about outgassing behaviour produced numbers roughly 6 times smaller. The adjustments reveal uncertainty, not resolution. Different models produce different results because the underlying physics is not well constrained. We are trying to explain an acceleration pattern that does not fit cleanly into our established frameworks for cometary behaviour. Avi Loeb has pointed out repeatedly that the magnitude of acceleration observed requires significant mass loss if produced by natural outgassing. The thrust must come from somewhere. Momentum is conserved. For a comet to accelerate, it must eject material in the opposite direction. The more acceleration you need, the more material you must expel. But the post-perihelion images show a nucleus that appears largely intact, not the shattered, dispersing remnant you would expect from an object that just expelled a significant fraction of its mass, not the diffuse cloud of debris that should mark catastrophic outgassing. Instead, a relatively compact source surrounded by those impossible jets. The alternative explanation is propulsion that does not rely on mass ejection at cometary velocities. Technological thrusters achieve much higher exhaust speeds, requiring far less fuel for equivalent momentum change. An object equipped with such systems could execute the observed manoeuvres while retaining the bulk of its mass, and perihelion would be the optimal time to use such systems. In astrodynamics, there is a technique called the Oberth maneuver. It exploits a counterintuitive property of orbital mechanics. When you fire your engines at the lowest point of your orbit, closest to the gravitational body you're orbiting, you get more bang for your buck. The same amount of fuel produces a larger change in your overall orbital energy when applied at high velocity near a gravity well than when applied at low velocity far away. Every spacecraft mission that uses gravity assists employs some version of this principle. Swing close to a planet, fire your engines at the closest approach, and you amplify the effect of your propulsion. It is basic rocket science, taught in every aerospace engineering program on Earth. 3I Atlas reached its closest approach to the Sun during the one period when Earth could not watch. If it needed to execute a major course correction, if it needed to shift its trajectory to achieve that precise Jupiter rendezvous, perihelion was the ideal moment. The Oberth effect would maximize the efficiency of any propulsion. The solar conjunction would minimize the risk of detection. A reverse Oberth maneuver, using the Sun's gravity well to brake rather than accelerate, would be the optimal strategy for an interstellar spacecraft seeking to slow down and take up residence in a target system. Such a manoeuvre would require engines, it would require fuel, it would require timing the burn for maximum efficiency, it would require doing it when no one could see. I want to be clear about the limits of our knowledge here. We do not have direct evidence that 3I Atlas executed any deliberate manoeuvres during perihelion. We have trajectory data that shows non-gravitational acceleration. We have post-perihelion images that show unexpected structures. We have the mathematical fact that the resulting path leads to Jupiter's hill radius with extraordinary precision. What we do not have is footage of engines firing. We do not have spectral signatures of exotic propellants. We do not have the smoking gun that would prove beyond doubt that something intelligent is at work. But absence of evidence is not evidence of absence, particularly when the absence occurs precisely during the window when observation was impossible. If you were designing a mission profile to avoid detection while executing critical maneuvers, you would choose exactly this geometry. Approach from the galactic centre where stellar crowding hampers early detection. Time your perihelion for solar conjunction with the target planet. Execute your burns behind the sun's glare. Emerge on your new trajectory looking like a natural comet that simply became more active near the sun. The perfect camouflage combined with the perfect timing. SOHO, the Solar and Heliospheric Observatory, did capture some images of 3I Atlas during the perihelion period. This joint NASA and ESA mission observes the sun continuously using a coronagraph that blocks the solar disk, allowing views of the surrounding corona and any objects passing nearby. 3I Atlas transited through SOHO's field of view in late October. The images show a bright object moving against the stellar background. They confirm that 3I Atlas survived perihelion intact, which was not guaranteed for a body passing that close to the sun. But the resolution is insufficient to reveal structural details. We see a dot of light, not an object. Whatever was happening at the surface, whatever jets were forming or maneuvers executing, remained below the threshold of detection. Mars-based observations filled some gaps, but not all. The brightness evolution, the general morphological category, the confirmation of ongoing activity, all useful, none definitive. What emerged when Earth could finally observe again was something different from what went in. The transformation was real. The cause remains uncertain. This uncertainty is not comfortable. As a scientist, I want answers. I want data that resolves ambiguity and explanations that account for observations. But science also requires honesty about what we do not know. And regarding those crucial weeks around perihelion, what we do not know vastly outweighs what we do. The hidden perihelion manoeuvre might have been nothing more than natural cometary evolution, thermal processing and outgassing responding to solar heating in ways we did not anticipate. Or it might have been the critical phase of a carefully planned mission, the moment when an interstellar visitor adjusted its course for final approach to its true destination. We will probably never know for certain. The moment has passed. The manoeuvres, whatever they were, have been executed. 3I Atlas is now on its post-perihelion trajectory, heading outward through the solar system, approaching Earth for its closest pass before continuing to Jupiter. But understanding what might have happened during those hidden weeks matters, because if 3I Atlas did execute deliberate manoeuvres, if it did adjust its course using the sun as a gravitational amplifier, then we are not dealing with a passive object following the dictates of celestial mechanics. We are dealing with something that acts, something that chooses, something that might have plans we have not yet imagined. And that raises a question we have been avoiding. What do we actually do about it? What response is even possible? What protocols exist for a situation that most governments insist could never happen? The answer might surprise you, and it might terrify you. First contact protocols and the silence of governments. In 1989, the International Academy of Astronautics established a document known as the Declaration of Principles concerning activities following the detection of extraterrestrial intelligence. It sounds impressive, official, the kind of thing that suggests someone, somewhere, has a plan for what happens if we discover we are not alone. The reality is far less reassuring. The declaration is not legally binding. It has no enforcement mechanism. It provides general guidelines suggesting that discoverers should verify their findings before announcement, notify relevant international bodies, and avoid transmitting any response without international consultation. These are polite suggestions, not protocols. They assume orderly scientific discovery in a controlled environment, not an anomalous object blazing through our solar system with characteristics that defy easy explanation. No government on Earth has an official, publicly acknowledged response plan for extraterrestrial contact. No military has published doctrine for engagement with non-human intelligence. No international body has the authority to coordinate a global response. We have spent decades arguing about this. Scientists have proposed frameworks. Philosophers have debated ethics. Science fiction writers have imagined scenarios. But when it comes to actual preparation, actual chains of command, actual contingency planning for a situation that could redefine human civilization, we have essentially nothing. The silence surrounding 3I Atlas takes on new meaning in this context. When the object was discovered in July, NASA and other space agencies issued measured statements. A new interstellar visitor, only the third ever detected. Scientifically interesting. No threat to Earth. The messaging was calm, professional, and almost aggressively mundane. Nothing to see here, just another comet, albeit from very far away. When Avi Loeb and his colleagues published their paper, exploring the possibility that 3I Atlas might be technological in origin, the response from the scientific establishment was swift and dismissive. Extraordinary claims require extraordinary evidence. We have seen unusual comets before. There is no reason to invoke aliens when natural explanations suffice. These responses are not unreasonable on their face. Scientific skepticism is a feature, not a bug. Jumping to exotic conclusions based on limited data is exactly what rigorous methodology guards against. But there is something else in the tone. A certain eagerness to close the book. A reflexive insistence that the question itself is unworthy of serious consideration. Kim Kardashian asked NASA about 3I Atlas on social media, and the acting administrator responded with cheerful dismissal. No aliens, no threat, nothing to worry about. How would he know? This is not a rhetorical question. Based on what evidence could anyone make definitive statements about the nature of 3I Atlas in the early months after discovery? The object was millions of kilometers away. Our observations were limited. The perihelion passage had not yet occurred. And yet the messaging was certain, confident. Case closed before the investigation had properly begun. I'm not suggesting a grand conspiracy. I'm suggesting something perhaps more troubling. Institutional incapacity to confront uncomfortable possibilities. Governments and scientific institutions are optimized for normal operations. They have procedures for known categories of events. When something arrives that does not fit those categories, the default response is to force it into the nearest existing box. Interstellar object becomes comet. Anomalous behavior becomes unusual outgassing. Mathematical improbabilities become coincidences. The alternative, admitting that we might be dealing with something genuinely unprecedented, opens doors that institutions are not prepared to walk through. It raises questions they cannot answer. It creates responsibilities they cannot fulfill, so they do not admit it. They maintain the narrative of normality even as anomalies accumulate. They dismiss rather than investigate. They reassure rather than inform. Meanwhile, behind closed doors, what is actually happening? This is where we enter the realm of informed speculation. The United States maintains space surveillance capabilities that far exceed anything publicly acknowledged. The Space Force, formerly Air Force Space Command, operates networks designed to track every object in Earth orbit and beyond. These systems were created primarily to monitor satellites and space debris, but they possess capabilities relevant to tracking deep space objects. The classified world includes sensors and analytical capabilities we can only guess at. When something unusual appears in our solar system, you can be certain that assets beyond NASA's civilian telescopes are brought to bear. Intelligence agencies have access to information that never reaches public scientific papers. Decisions are made in rooms the press never enters. The question is not whether governments are paying attention to 3I Atlas. The question is what they know that we do not. Consider the timing of certain events. The International Asteroid Warning Network, an organisation that tracks potentially hazardous asteroids, announced a special astrometry campaign for 3I Atlas, running from November 27th through January 27th. This is the same network that sounded alarms earlier this year when asteroid 2024 YR4 appeared to be on a potential collision course with Earth. Why would an asteroid warning network launch a dedicated campaign for an object that poses no collision risk? Official explanations cite scientific interest in refining the trajectory of an unusual visitor. Skeptics might note that intensive tracking campaigns are typically reserved for objects that warrant serious concern. The government shutdown that briefly affected NASA in early October coincided with 3I Atlas approaching its perihelion. Routine budget impasse, the official explanation states. No connection to any celestial events, perhaps. But the timing meant reduced NASA operations during the very window when the object was hidden from most observation. I'm not claiming these events are connected. I am noting that they create a pattern of reduced transparency precisely when transparency would be most valuable. What would actual preparation for an extraterrestrial event look like? This is worth considering, even hypothetically. The United States Air Force maintains units called Space Aggressor Squadrons. These are real. The 26th and 527th Space Aggressor Squadrons, based in Colorado, are tasked with developing strategies to counter threats to American space assets. Their primary concern is adversary nations like China and Russia, which possess demonstrated capabilities to interfere with satellites. But their mandate includes responding to any threat to space-based infrastructure. No official acknowledges that this mandate extends to extraterrestrial scenarios, but the capability exists. The personnel are trained in threat assessment and response. The infrastructure for coordinated space-based defense, such as it is, already operates. The multinational space collaboration effort brings together allied nations to build mutual defense systems for space assets. Again, officially focused on terrestrial adversaries. But collaborative frameworks for space security could theoretically be adapted for other purposes. These are not secret organizations. They are publicly acknowledged. What remains unclear is the extent of their contingency planning and whether scenarios beyond conventional military threats have ever been seriously gamed. History offers some precedent for government response to potential extraterrestrial encounters. In 1960, the Brookings Institution prepared a report for NASA titled Proposed Studies on the Implications of Peaceful Space Activities for Human Affairs. This document included a section on the discovery of extraterrestrial life and its potential social impacts. The report suggested that such a discovery could be destabilizing, particularly for religious institutions and cultures with strongly held beliefs about human uniqueness. Some have interpreted this report as recommending suppression of evidence for extraterrestrial intelligence should such evidence emerge. The actual text is more nuanced, suggesting careful study of how to manage disclosure rather than advocating permanent concealment. But the report demonstrates that government institutions have contemplated these questions for decades. What conclusions they reached, what policies they adopted remains unknown. More recently, the Pentagon established the All-Domain Anomaly Resolution Office, originally focused on unidentified aerial phenomena reported by military personnel. This office represents official acknowledgement that anomalous sightings occur and warrant serious investigation. Its creation followed years of leaked videos and congressional pressure. The existence of such an office suggests that at least some parts of the government take unexplained phenomena seriously. Whether their mandate extends to interstellar objects like 3I Atlas is not publicly stated. All of this adds up to a troubling picture. We have institutions capable of response but no acknowledged protocols for the specific scenario we might be facing. We have surveillance capabilities but no transparency about what they reveal. We have officials offering reassurance but no basis for their confidence. The silence of governments might reflect genuine ignorance. They might know no more than the public, simply monitoring the situation with the same instruments and reaching the same uncertain conclusions. The dismissive rhetoric might be genuine belief rather than strategic messaging. Or the silence might reflect something else entirely. Knowledge that would destabilize if widely shared. Preparations being made outside public view. Decisions about how much to reveal and when. I cannot tell you which scenario is correct. Neither can anyone outside the classified world. But I can tell you that blind trust in official reassurances is not warranted. The institutions telling us not to worry are the same institutions that maintained for decades that they took no interest in unidentified aerial phenomena, while simultaneously collecting and analysing reports in secret programs. Credibility is earned through transparency, and on the subject of 3I Atlas, transparency has been notably lacking. What happens if the coming weeks reveal something that cannot be dismissed? What happens if observations during the closest approach to Earth show characteristics that no natural explanation can accommodate? What happens if the Jupiter rendezvous produces evidence of deployment of devices separating from the main body and taking up residence in Jovian orbit? The answer is that we do not know because no one has told us. The plans, if they exist, remain secret. The protocols, if any, have never been exercised. We would be navigating unprecedented territory with no map and no guide. This is the reality we face. Not just an anomalous object in our solar system, but an apparatus of governance utterly unprepared to confront its implications. And as 3I Atlas approaches, as the days count down toward December 19th and the weeks toward March, we wait for answers that may never come from official sources. Perhaps the answers will have to come from somewhere else, from independent observers, from scientists willing to ask uncomfortable questions, from a public that refuses to accept dismissal as adequate response. Or perhaps the answers will come from 3I Atlas itself, in actions rather than words, in events rather than explanations. If there is something aboard that object with intentions toward Earth, what form might those intentions take? What would the opening moves of an actual engagement look like? Not science fiction scenarios of fleet battles and death rays, but realistic assessment of capabilities and vulnerabilities. This is not comfortable territory, but comfort is not what this moment requires. The mass ejection problem numbers do not lie. They can be misinterpreted, manipulated, or misunderstood, but the numbers themselves are simply what they are. And the numbers surrounding 3I Atlas have been telling us something from the very beginning, something that most analysts have been reluctant to confront directly. The mass ejection problem is not a minor discrepancy. It is a fundamental inconsistency at the heart of the natural comet explanation, a contradiction so severe that resolving it requires either abandoning basic physics or accepting possibilities that most scientists find professionally uncomfortable. Let me walk you through it, step by step. Before perihelion, 3I Atlas showed minimal non-gravitational acceleration. This was carefully measured through tracking data from hundreds of observatories between July and September. The object moved along an almost purely gravitational trajectory, its path shaped by the sun's pull with no detectable thrust from outgassing. This stability allowed astronomers to estimate the object's mass. The logic is straightforward. If a comet is actively releasing gas, and that gas is not producing measurable acceleration, then either the outgassing rate is negligibly small, or the comet is so massive that the resulting thrust is lost in the noise. Given that 3I Atlas had a visible coma during this period indicating significant activity, the low-mass scenario was untenable. The conclusion was that 3I Atlas must be very heavy, at least 33 billion tons based on nucleus size estimates and reasonable density assumptions. Then came perihelion, and everything changed. The trajectory data from late October and November revealed clear non-gravitational acceleration. Something was pushing on 3I Atlas, changing its velocity in ways that gravity alone could not explain. For a natural comet, this push comes from outgassing. Gas is released from the surface, it expands into space, and by Newton's third law the nucleus experiences a reaction force in the opposite direction. The magnitude of acceleration observed allows us to calculate the required thrust. The required thrust tells us the momentum being carried away by the outgassed material, and the momentum of that material is simply its mass times its velocity. For cometary outgassing, the typical velocity is around 400 meters per second. This is determined by the physics of ice sublimation, the thermal energy available, and the molecular mass of the released gases. It is not a variable we can adjust arbitrarily. It is set by fundamental chemistry. If you need a certain amount of thrust and you know the velocity of your exhaust, you can calculate how much mass must be expelled. The numbers are relentless. To generate the observed acceleration of 3I Atlas during perihelion, assuming standard cometary outgassing velocities, the object must have ejected roughly 10 to 20% of its total mass. For a 33 billion ton comet, that is 3 to 7 billion tons of material. And some analyses suggest even higher figures, potentially exceeding the estimated total mass itself. Where is it? This is not an abstract question. Billions of tons of gas and dust do not vanish. They spread through space, scattering sunlight, producing characteristic emission spectra, creating an extended cloud that should be visible to any telescope pointed in the right direction. Post-perihelion observations show an active comet, bright coma, multiple jets, significant ongoing activity. but not the catastrophic dispersal that should accompany the loss of a substantial fraction of the nucleus mass. The images from Dewitt and Liu on November 11th show a compact central source. The images from various amateur astronomers show concentrated brightness, rather than diffuse spreading. The debris cloud is not there, not at the scale required. Several explanations have been proposed, none entirely satisfactory. Perhaps the mass estimates were wrong from the beginning. Perhaps 3i Atlas is much more massive than the 33 billion ton minimum, so massive that losing several billion tons barely registers as a perturbation. This would require a nucleus far larger than current observation support. The lack of resolved imaging makes definitive size determination difficult, but no data suggests we are dealing with an object dramatically larger than 5 to 10 kilometers in diameter. Perhaps the outgassing was more efficient than typical comets. Perhaps some exotic volatile sublimated at unusually high velocities, reducing the mass required for a given thrust. Carbon monoxide and carbon dioxide sublimate more readily than water ice, and spectra do show significant CO2 in the coma. But the velocity differences are factors of 2 or 3, not orders of magnitude. You cannot close the gap this way. Perhaps the non-gravitational acceleration was concentrated in a brief, intense burst, rather than spread over the full perihelion passage. A shorter burst requires less total mass for the same integrated velocity change. But this just shifts the problem. A burst powerful enough to redirect a 33 billion ton object would produce a visible event, a sudden brightening, a flare of escaping material. Nothing of that magnitude was observed in the available data, though admittedly the perihelion window had limited coverage. Or perhaps, and this is the possibility that haunts the edges of this conversation, the acceleration did not come from mass ejection at all. Consider what we know about technological propulsion. Chemical rockets achieve exhaust velocities of 3 to 5 kilometers per second. Ion thrusters reach 20 to 50 kilometers per second. Theoretical advanced propulsion concepts like nuclear thermal or fusion drives could go higher still. Thrust is mass times velocity. If you increase velocity, you need less mass for the same thrust. The relationship scales linearly. Double your exhaust velocity, halve your required propellant. An object equipped with propulsion systems achieving even modest technological performance could execute the observed maneuvers while consuming only a fraction of the mass required for natural outgassing. A chemical thruster would need roughly 10 times less propellant than cometary sublimation. An ion drive would need 50 to 100 times less. The mass ejection problem disappears if you assume technology. I am not asking you to accept this conclusion. I am asking you to recognize that it resolves an otherwise intractable inconsistency. The natural explanation requires physics to work differently than we understand. The technological explanation requires only that intelligence exists elsewhere and has reached our solar system. Neither is proven. But only one requires new physics. The jets themselves provide additional evidence worth examining. Natural cometary jets arise from localized regions of volatile ice that become active when heated. They are subject to the rotation of the nucleus, typically appearing as curved structures as the comet spins. They emerge from specific spots on the surface where subsurface reservoirs connect to the exterior. The jets of 3i Atlas do not behave this way. As mentioned previously, they maintain directional stability despite the 16-hour rotation period. They extend in multiple directions simultaneously, including sunward against the solar wind. They persist over timescales that should disperse them into undetectable diffuseness. If these are natural jets, they require surface conditions unlike any comet previously studied. Multiple active regions precisely positioned to produce symmetrical outflows. Emission rates balanced to maintain structural coherence. Volatile reservoirs that somehow coordinate their activity across the entire nucleus. Alternatively, they are not natural jets at all. They are engineered outputs from systems designed to produce specific effects. Thrusters arranged for maneuvering capability. Dispersal mechanisms releasing material in controlled patterns. The visual signature of technology masquerading as nature. The distinction matters enormously for what happens next. A natural comet will continue behaving according to physics we understand. Its activity will fade as it recedes from the sun, and volatile reservoirs deplete. It will pass Jupiter according to predictable orbital mechanics. It will exit the solar system as it entered, a visitor shaped by forces beyond its control. A technological object has options. It can change course. It can release payloads. It can respond to circumstances in ways that purely physical systems cannot. Its behaviour near Jupiter will be governed not by chemistry, but by intention. We will have opportunities to test these possibilities in the coming months. Spectroscopic analysis of the jets could reveal their velocity structure. Natural sublimation produces specific speed distributions based on thermal physics. Technological exhaust would show different signatures. The James Webb Space Telescope has the capability to make these measurements if properly targeted. Continued trajectory monitoring will reveal whether 3I Atlas follows the expected gravitational path or shows additional deviations. Any course corrections after the perihelion burn would be extremely difficult to explain naturally. Objects do not spontaneously change direction in deep space. Observations at Jupiter could detect released objects, though this is challenging at extreme range. Any satellites deployed into Jovian orbit would need to be substantial to be detectable, but their presence would be definitive proof of technological origin. These tests are coming. The data will accumulate, and one way or another, the mass ejection problem will be resolved. Either we will find explanations that salvage the natural comet hypothesis, or we will be forced to confront alternatives that remake our understanding of our place in the cosmos. What I find most striking about this situation is how few people seem to appreciate its significance. The mass ejection problem is not a minor technical detail. It is a fundamental challenge to the standard narrative, and yet the scientific establishment has largely ignored it, preferring reassurance over rigour. I understand the impulse. Acknowledging the problem means acknowledging uncertainty. Acknowledging uncertainty means acknowledging possibility. And acknowledging the possibility that 3I Atlas might be technological opens professional doors that most scientists would rather keep closed. But science is not supposed to be comfortable. Science is supposed to follow evidence wherever it leads, even when that direction is inconvenient. The mass ejection problem is evidence. The jet behaviour is evidence. The trajectory precision is evidence. Evidence does not care about our preferences. It simply is what it is. The numbers are not lying. They are telling us that something about 3I Atlas does not add up. And until we resolve that discrepancy honestly, we cannot claim to understand what is passing through our solar system. The 50 billion tons per month, the intact nucleus, the impossible jets, the hidden manoeuvres, the precision trajectory. Each anomaly might have an innocent explanation, but stacked together they form a pattern that looks less like coincidence with every new observation, a pattern that might just be the signature of something we have been looking for since we first raised our eyes to the stars, or something that has been looking for us. Gadgets from the stars. Imagine for a moment that you are an intelligence operating on timescales we can barely comprehend. Your civilization has existed for millions of years, perhaps billions. You have mapped the galaxy. You know which stellar systems contain planets, which of those planets might harbour life, which might evolve toward technological capability. You are patient in ways that biological creatures with century-long lifespans cannot be. How would you explore? How would you monitor? How would you seed the galaxy with your presence across distances that light itself needs thousands of years to cross? You would send probes, autonomous systems capable of operating indefinitely without supervision, self-repairing, self-directing, programmed with goals that unfold over eons rather than decades. And you would design those probes to be unobtrusive, to blend with the natural phenomena of the cosmos, to watch without revealing themselves until circumstances warranted. This is not science fiction. This is the logical consequence of applying our own technological trajectory to civilizations older than ours. We have already sent probes beyond our solar system. Voyager 1 and 2 carry plaques, and golden records intended as messages to anyone who might find them. Pioneer 10 and 11 bear their own symbols. These are crude first attempts, limited by the technology of the 1970s, but they establish the principle. We send things to watch and to be watched. A civilization millions of years ahead of us would do the same thing, except incomprehensibly better. The concept of self-replicating probes was first rigorously analysed by mathematician John von Neumann in the 1940s. His theoretical work on self-reproducing automata established that machines could, in principle, construct copies of themselves using raw materials from their environment. Applied to space exploration, this implies that a single probe could arrive at a new star system, use local resources to build additional probes, and send those copies to further destinations. The mathematics of exponential growth are startling. If each probe produces 2 copies and each copy takes 1,000 years to reach a new system and replicate, then within 10 million years, a single initial probe could have descendants in every star system in the galaxy. 10 million years is nothing on cosmic timescales. The Milky Way is over 13 billion years old. There has been ample time for this process to occur multiple times over. The implication is profound. If self-replicating probes are possible, and if any civilization anywhere in the galaxy ever deployed them, then those probes should already be here. Not arriving now for the first time, but having arrived long ago and watched silently ever since. Fermi's paradox asks why we have not detected evidence of extraterrestrial intelligence despite the mathematical likelihood that it exists. The von Neumann probe scenario deepens this paradox by suggesting that evidence should be everywhere, not rare. The galaxy should be saturated with ancient machines, unless those machines are designed to remain undetected, unless their purpose is observation rather than contact, unless they reveal themselves only when specific conditions are met. 3i Atlas approaches Jupiter, heading for a rendezvous at the precise edge of the planet's gravitational sphere of influence, the Hill radius, the boundary where stable orbits become possible, the perfect location to deposit objects that will remain in place indefinitely without intervention. What might such objects be? Surveillance platforms are the most conservative possibility. Devices designed to monitor electromagnetic emissions, track spacecraft, observe planetary surfaces. Our own civilization produces similar technology. Spy satellites orbit Earth in their thousands, watching everything, listening to everything. A probe network positioned around Jupiter could observe the entire inner solar system, including Earth, from a vantage point that our detection capabilities cannot easily reach. Communication relays represent another possibility. Interstellar distances make real-time communication impossible, but a network of relay stations could dramatically reduce transmission times within a stellar system. Devices at Jupiter, at Saturn, in the asteroid belt, in the Oort cloud, could form the local nodes of a network spanning countless star systems. When 3i Atlas departs our solar system, it might be connecting us to a web that already exists. More speculatively, the deposited devices could be manufacturing platforms, self-replicating machines that use resources from Jupiter's moons or the asteroid belt to construct additional technology. These factories could operate for millennia, slowly building infrastructure we would never detect until it was far too advanced to oppose. Or they could be dormant capabilities, weapon systems waiting for activation, defense platforms ready to respond to specified threats. The dark forest hypothesis suggests that civilizations in the cosmos eliminate potential competitors before they become dangerous. A probe network positioned in every stellar system could be the enforcement mechanism of some ancient galactic order, ready to sterilize planets that develop spacefaring capability. I do not suggest this to frighten you. I suggest it because intellectual honesty requires considering the full range of possibilities. The same technology that could passively observe could actively intervene. We have no way of knowing which purpose, if any, drives what we are seeing. The behaviour of 3i Atlas is consistent with deployment preparation. The perihelion manoeuvre that corrected its course toward Jupiter, the emergence of multiple jets that might represent final system tests or payload separation procedures, the approach to the Hill radius where deposited objects would find gravitational stability. If something is released during the Jupiter flyby, what would we see? Probably nothing. The distances are too great and our instruments too limited. Juno orbits Jupiter focused on the planet itself, not on tracking small objects in high orbits. JUICE is still years from arrival. Earth-based telescopes see 3i Atlas as a point of light at best. Any devices released would need to be quite large to be detectable from our current observational positions. A few meters across would vanish into the background noise. Even kilometre-scale objects would be challenging to spot against the glare of Jupiter and the darkness of deep space. This is perhaps the most disturbing aspect of the scenario. We could be watching the seeding of our solar system with extraterrestrial technology and lack the capability to confirm it. We might suspect but never know. We might speculate but never verify. The uncertainty is itself a feature, from the perspective of whoever designed this system. Plausible deniability, sufficient ambiguity to prevent definitive conclusions, evidence that raises questions but does not answer them. There is another possibility worth considering. What if 3i Atlas is not the deployment mechanism, but rather the signal? What if its passage through our solar system serves to announce something rather than deliver something? Consider how we might detect incoming interstellar objects. We need telescopes sensitive enough to spot them, processing systems capable of recognizing their trajectories as unusual, institutional frameworks for following up on discoveries. All of these capabilities have developed only recently in human history. The Atlas Telescope network that found 3i Atlas came online within the past decade. The Vera Rubin Observatory that will revolutionize interstellar object detection is just now beginning operations. An intelligence monitoring Earth might have waited for precisely these developments, waited until we could see before sending something to be seen. The timing of 3i Atlas, arriving just as our detection capabilities reached the threshold required to notice it, might not be coincidental. In this interpretation, the object itself is the message. Its anomalies are designed to be noticed. The trajectory precision, the impossible jets, the mass ejection discrepancies, all of it serves to attract attention, to raise questions, to force contemplation of possibilities we would otherwise ignore. The message content might be as simple as we are here: proof of existence, demonstration of capability, an announcement that the galaxy is not empty, and that someone has taken notice of the peculiar species inhabiting the third planet of an unremarkable yellow star. Or the message might be more complex, a test of our analytical capabilities, an assessment of how we respond to anomalies, data collection not through observation, but through provocation, watching how our species reacts when confronted with the unexplainable. The ancient Greeks told stories of gods who walked among mortals in disguise, testing their hospitality, their wisdom, their worthiness. We might be undergoing a similar examination, with 3i Atlas as the wandering stranger whose true nature remains hidden until the final moment of judgment. This is mythology, not science. But mythology often encodes truths that formal analysis misses. The pattern of hidden visitation, of tests administered by superior beings, of consequences that follow from how those tests are answered, this pattern repeats across human cultures. Perhaps it repeats because it describes something real. We are being watched. This much seems increasingly certain. Whether through passive observation or active deployment, 3i Atlas represents attention from elsewhere. The question is what that attention means and what response it expects. The gadgets from the stars might already be in place, seeded by previous visitors we never detected. They might be arriving now, carried by the object currently traversing our solar system, or they might remain hypothetical, possibilities we cannot confirm with our current level of technology. What we can do is prepare. Not militarily, which would be absurd given the presumed capability gap, but intellectually. We can develop better instruments. We can formulate protocols for anomaly response. We can build international frameworks for coordinated observation and analysis. Most importantly, we can abandon the reflexive dismissal that has characterized official response to 3i Atlas. We can take the anomalies seriously rather than explaining them away. We can ask questions even when the answers might be uncomfortable. December 19th approaches, then March and the Jupiter rendezvous, then the long departure toward interstellar space. Whatever 3i Atlas leaves behind, in orbit around Jupiter or in orbit around our assumptions, will shape the future of our species in ways we cannot yet imagine. The gadgets from the stars might be instruments of enlightenment or instruments of destruction. They might welcome us into a galactic community or mark us for exclusion. We do not get to choose what they are. We only get to choose how we respond. And the quality of that response begins with honestly confronting what we are facing. Which brings us to a question we have been circling throughout this documentary. If 3i Atlas is not a passive comet but an active presence with unknown intentions, what can we actually do about it? What options does Earth have when confronted with technology that crossed light years to reach us? The answer is sobering. But it is not entirely hopeless. Earth's impossible defense. Let us be honest about something that most discussions of extraterrestrial contact carefully avoid. If 3i Atlas represents a technological civilization capable of interstellar travel, and if that civilization harbours hostile intentions toward Earth, we have essentially no defense. This is not defeatism, it is physics. Any species that can send functional probes across the light years separating star systems possesses capabilities so far beyond our own that comparison becomes almost meaningless. The energy requirements for interstellar travel dwarf anything humanity has ever produced. The material science needed to build vessels that survive decades or centuries of cosmic radiation, micrometeorite impacts, and the stresses of acceleration and deceleration exceeds our current understanding. The computational power required to navigate, communicate, and operate autonomously across interstellar distances implies artificial intelligence far more sophisticated than anything we have created. In military terms, this represents what strategists call an asymmetric capability gap. Not a difference of degree, but a difference of kind. It is not like facing an enemy with better tanks or faster aircraft. It is like a medieval army facing a modern military force. The categories of warfare simply do not translate. Our nuclear arsenals, the most destructive weapons humanity has devised, deliver yields measured in megatons of TNT equivalent. An interstellar civilization would think nothing of directing asteroid impacts that release thousands of times more energy. Our missiles travel at kilometers per second. Anything crossing interstellar space routinely operates at tens of kilometers per second, and advanced propulsion could approach significant fractions of light speed. We cannot intercept what we cannot detect. We cannot detect what we cannot understand. We cannot understand technology thousands or millions of years beyond our own. This is the sobering foundation of any honest assessment of Earth's defensive posture. Against an interstellar threat, we have no meaningful military options. But hopelessness is not the only possible conclusion, because the assumptions underlying military confrontation may themselves be flawed. Consider what hostile intention would actually mean in this context. Why would an advanced civilization cross light years to attack Earth? What could we possibly have that they would want badly enough to justify the investment? Resources seem unlikely. Everything available on Earth, water, metals, organic compounds, exists in vastly greater quantities throughout the galaxy. The asteroid belt alone contains more accessible mineral wealth than our entire planet. The outer solar system holds more water than all of Earth's oceans combined. A civilization capable of interstellar travel has no need to come to our gravity well for raw materials. Living space is similarly implausible. Terraforming planets is extraordinarily difficult, and any species that has mastered interstellar travel has presumably also mastered the construction of artificial habitats. Space stations, O'Neill cylinders, orbital infrastructure, all of these would be easier to build than conquering and adapting an alien biosphere. Perhaps they want to eliminate potential competitors. This is the dark forest hypothesis in its starkest form. Intelligent species destroy each other preemptively because any civilization could eventually become a threat. Better to strike now while the target is primitive than wait until they develop dangerous capabilities. But this logic contains a flaw. If elimination were the goal, why send scouts? Why approach gradually? Why give us any opportunity to notice? A civilization that truly wanted to erase humanity could do so with a kinetic impactor from the Oort cloud, accelerated years ago, travelling toward us right now at speeds we could never detect. No warning, no negotiation, no three-eye atlas announcing its presence. The very fact that we are having this conversation suggests that elimination, if it is the intent, is not the immediate plan. Something more subtle is happening, or perhaps hostile intention is the wrong frame entirely. Perhaps what looks like threat is actually something else. Consider how we interact with less advanced species on our own planet. We study them. We observe their behaviour. We sometimes interfere in ways that must seem bizarre or threatening from their perspective. Wildlife biologists capture animals, tag them with tracking devices and release them. To the animal, this is an incomprehensible trauma, an abduction and assault by strange beings wielding incomprehensible technology. From our perspective, it is science. Three-Eye Atlas might be the cosmic equivalent of a tagging operation, an observation platform documenting Earth's development for reasons we cannot fathom. Interference not for harm, but for understanding. This is admittedly speculative. We have no way to know the intentions of an intelligence we have not confirmed exists, but it suggests that military defence, even if it were possible, might be the wrong response entirely. What responses might actually be appropriate? The first and most important is enhanced observation. We need better tools to understand what Three-Eye Atlas actually is. Dedicated spectroscopic campaigns to analyse the jet composition and velocity. Continuous trajectory monitoring to detect any anomalous course changes. coordination between ground-based observatories, space telescopes, and interplanetary probes to build a complete picture. This is already happening to some extent. Observatories worldwide are tracking the object. The James Webb Space Telescope has capabilities relevant to this investigation. NASA's deep space assets are being tasked with supplementary observations, but the effort is fragmented, underfunded, and constrained by institutional reluctance to take the anomalies seriously. A truly appropriate response would dedicate significant resources to comprehensive study, treating 3I Atlas as the priority target it arguably is rather than just another interesting comet. The second response is transparency. Whatever we learn should be shared widely, rather than compartmentalized. Scientific findings should be published openly. Government assessments should be disclosed. The public should be informed to the extent current knowledge permits. This runs counter to institutional instincts towards secrecy, but secrecy serves no useful purpose here. If 3I Atlas is a natural phenomenon, transparency costs nothing. If it is something else, public knowledge allows broader participation in analysis and response. Concealment only breeds distrust and hinders the collective intelligence that complex problems require. The third response is communication. If we are being observed, we might as well acknowledge it. Transmissions directed toward 3I Atlas, even if unlikely to be received or understood, establish our awareness and our willingness to engage. This is controversial. Some argue that drawing attention to ourselves is dangerous, that the dark forest hypothesis implies we should hide rather than announce our presence. But this argument fails on examination. Any civilization capable of sending 3I Atlas already knows we exist. Our radio transmissions have been leaking into space for over a century. Our atmospheric chemistry shows obvious signs of industrial activity. We are not hidden and cannot become so. Attempting communication demonstrates something important. It shows that we recognize the possibility of non-human intelligence. It shows that we are open to contact rather than reflexively hostile. It establishes a posture of curiosity rather than fear. If 3I Atlas is a test, communication might be the correct answer. The fourth response is preparation for contact scenarios that may unfold over coming decades rather than immediately. Whatever 3I Atlas is, it is not the last interstellar object we will encounter. The Vera Rubin Observatory will detect many more in coming years. Our solar system appears to be regularly visited by debris from other stellar systems. Eventually something will arrive that is unambiguously artificial. Eventually we will face questions that cannot be deflected with reassurances about comets. We should use the time between now and then to develop frameworks for response, protocols for communication, institutions capable of coordinating humanity's reaction. This is what we can do. Not military defense, which is impossible, but preparation. Building the observational capabilities to know what we're dealing with. Establishing the transparency to process that knowledge collectively. Developing the communication posture to engage rather than retreat. Creating the institutional structures to respond wisely when the moment of clarity arrives. None of this addresses the immediate question of 3I Atlas itself. If it releases technology at Jupiter, we cannot stop it. If it changes course toward Earth, we cannot intercept it. If it has already seeded our solar system with observation platforms, we cannot locate or disable them, but we can choose how we confront our own uncertainty. We can choose to face the unknown with open eyes rather than hiding behind dismissals. We can choose to prepare rather than deny. The universe is not obligated to be safe. It is not designed for our comfort. 3I Atlas reminds us that we are small, that we are young, that we are one species on one planet in a galaxy containing hundreds of billions of stars. Our military power, which seems so formidable in terrestrial contexts, is nothing against the vastness of space and time, but our curiosity, our adaptability, our capacity for cooperation and creativity, these might matter. These might be the things that determine not whether we survive an encounter with extraterrestrial intelligence, but how we emerge from it. The impossible defense is not about weapons, it is about wisdom. And wisdom begins with accepting what we cannot change while working to shape what we can. 3I Atlas approaches. We cannot turn it away. We cannot know its purpose with certainty, but we can watch. We can learn. We can think carefully about what we observe and what it means. This is our defense. Not guns and missiles, but minds and telescopes, not force. but understanding. And perhaps, in the end, that is exactly what is being tested. The reconnaissance theory. There is an alternative to the invasion hypothesis that deserves careful consideration. What if 3i Atlas is not the main event but rather the preliminary survey? What if we are witnessing not an attack but reconnaissance? Not the army but the scouts sent ahead to map the terrain. In military doctrine, reconnaissance serves several purposes. It gathers information about enemy positions and capabilities. It identifies vulnerabilities and potential approach routes. It tests defences to see how they respond to provocation. And critically, it reports back to the main force, enabling informed decision-making about whether, when, and how to proceed. Applied to the cosmic context, this framework suggests a profoundly unsettling possibility. 3i Atlas might be gathering intelligence that will inform future decisions by an intelligence we have not yet encountered. Consider what could be learned from a passage through our solar system. First, and most obviously, observation. A probe equipped with appropriate sensors could catalogue every significant body in our system, from the Sun to the outer planets to the asteroid belt. Orbital parameters, atmospheric compositions, surface features, all of it could be recorded in passing. We have done similar things with our own spacecraft. Voyager and Pioneer carried instruments that studied every planet they passed. New Horizons photographed Pluto in detail during its brief flyby. An advanced probe could do vastly more. Spectroscopic analysis of Earth's atmosphere would reveal the chemical signatures of life and industry. Radio emissions leaked from our planet would indicate the presence and approximate level of technological civilization. Thermal signatures would map population centres and industrial activity. None of this would require close approach to Earth. From the distances 3i Atlas maintains, sufficient data could be gathered to build a comprehensive profile of our species, our capabilities, our distribution, and our vulnerabilities. Second, response testing. How does humanity react to anomalies? Do we notice unusual phenomena? Do we investigate or dismiss? Do we cooperate internationally or fragment into competing factions? Do we respond with curiosity or fear? The passage of 3i Atlas provides answers to all of these questions. Our detection systems found it, demonstrating a threshold level of observational capability. Our scientific institutions studied it, revealing our analytical methodologies. Our governments issued reassurances, showing how political systems manage potentially destabilizing information. Our public discussed it on social media, exposing our communication patterns and concerns. All of this is data. All of it could be collected by something watching from within the coma of a seemingly natural comet. Third, capability, assessment. What could we do if we tried? Our spacecraft tracking systems reveal their range and precision. Our telescope networks show what we can see and what we miss. Our space launch capabilities, our orbital infrastructure, our deep space assets, all of this is observable by anything passing through our system with sufficient sensors. We have demonstrated to 3i Atlas exactly what our current technological level is. We have shown our strengths and our limitations. We have provided a detailed inventory of our capacity to detect, respond to, and potentially interfere with future arrivals. For a civilization planning eventual intervention, this information would be invaluable. It would enable precisely calibrated approaches, timing arrivals to exploit blind spots, choosing approach vectors that minimize detection risk, anticipating our responses before we make them. The reconnaissance theory implies that 3i Atlas is part of a larger operation, a single data-gathering mission in a process that might span decades, centuries, or longer. The scouts report back, the intelligence is analysed, decisions are made, and eventually, if the analysis warrants, something else arrives. This is more frightening in some ways than immediate invasion. Immediate invasion at least has clarity. You know what you are facing. You know the threat is present. You can respond even if that response is inadequate. But reconnaissance introduces uncertainty that extends indefinitely into the future. 3i Atlas departs, and we are left wondering. Was it just a scout? Is something else coming? When? In what form? With what intent? The psychological weight of perpetual uncertainty may itself be part of the test. How does a species respond to knowing it might be watched, might be judged, might face consequences it cannot anticipate? Does it collapse into paranoia? Does it ignore the possibility and return to normal life? Does it change behaviour? And if so, how? These are not abstract considerations. They are the questions that will shape human society in the wake of 3i Atlas, regardless of what the object actually is. The alternative to invasion might be evaluation, a cosmic performance review where the criteria are unknown and the consequences of failure are unspecified. There are historical analogies that illuminate this dynamic, though none are perfect. When Europeans first made contact with isolated indigenous societies, the pattern was often similar. Initial observation from a distance, tentative approaches to assess reaction, gradual escalation of contact as information accumulated. The indigenous societies rarely understood they were being evaluated until the evaluation was complete and its consequences were being implemented. From the perspective of those being observed, the process looked like random encounters with strange visitors. From the perspective of those observing, it was systematic data collection, informing strategic planning. We might be the indigenous society in this analogy. 3i Atlas might be one of many visits, perhaps the first we noticed but not the first that occurred. The scouts have been coming for years, decades, centuries, building profiles, tracking development, watching us grow from agricultural to industrial to nuclear to digital civilization, waiting for something, a threshold, a trigger, a moment when the gathered data supports action of some kind. This is speculation, of course. We have no evidence of previous interstellar visitors, though absence of evidence is not evidence of absence when detection capabilities were primitive. But the pattern makes a certain kind of sense. It is how we would behave if we were the advanced civilization observing a developing species on a planet across the galaxy. And that is perhaps the most useful analytical tool we have. Anthropic reasoning. Asking what we would do if we were them, and using those answers to interpret what we observe. If we were an advanced civilization that had discovered a planet bearing life on the verge of technological capability, we would watch, we would study, we would try to understand before we intervened. We would send probes disguised as natural phenomena to minimize interference with natural development while maximizing information gathering. We would send something very much like 3i Atlas. The reconnaissance theory does not preclude eventual contact or even eventual invasion. It simply suggests that 3i Atlas is a preliminary phase rather than a definitive event. What follows depends on what the reconnaissance reveals and how whatever is behind it interprets the data. We are being evaluated by something, for something, and we do not know the rubric. This uncertainty will persist long after 3i Atlas departs. It will colour how we think about the cosmos, how we respond to future anomalies, how we imagine our place in a universe that suddenly seems less empty than we assumed. In a sense, the reconnaissance has already succeeded. It has changed us, not through any action, but through the mere possibility that action could come. We cannot return to innocent ignorance now that the questions have been raised. Some will dismiss this as paranoia, some will embrace it as confirmation of beliefs they already held. Most will occupy the uncomfortable middle ground of genuine uncertainty, neither convinced nor dismissive, aware that the truth is unknowable with current evidence. This middle ground is perhaps the healthiest response, not certainty in either direction, but honest acknowledgement of ambiguity. We do not know what 3i Atlas is. We do not know why it came. We do not know what follows its departure, but we can observe, we can analyse, we can prepare as best we can for possibilities we cannot specify, and we can maintain the humility that comes from recognising the limits of our knowledge. The scouts may have come and gone. The report may be filed somewhere across the light years, in archives we cannot access about a species we are only beginning to understand we might be. What matters now is what we do with the knowledge that we might be watched. How we develop, how we treat each other, how we reach toward the stars that suddenly seem less indifferent than before. 3i Atlas departs toward Jupiter and then toward interstellar space. But its passage leaves a residue in our consciousness, a question that will not quite resolve. Were we visited? Are we being evaluated? And what happens when the evaluation is complete? The countdown continues. 20 days to closest approach, then the long recession toward the edge of our system and beyond, and behind it, the weight of possibility. The reconnaissance theory suggests this is not goodbye, but merely the end of Phase 1. The scouts have reported. Whatever comes next depends on what they found. We should hope they were impressed by something, because the alternative might be worse than we can imagine. the countdown to December 19th. 20 days. In 20 days, 3I Atlas will reach its closest point to Earth, 270 million kilometres, roughly 1.8 astronomical units, the nearest our interstellar visitor will ever come to the planet that has watched its passage with growing fascination and deepening concern. And then it will be gone, heading outward toward Jupiter, toward the frozen reaches of the outer solar system, and eventually back into the interstellar void from which it came. The window is closing. Whatever 3I Atlas is, whatever it means, whatever it might do, the time for observation is finite. This is not a drill. This is not a hypothetical scenario in an astronomy textbook. This is happening now, in our sky, on a schedule set not by human planners but by the cold equations of orbital mechanics. The coming 3 weeks represent our best opportunity to gather definitive data. As 3I Atlas approaches closest approach, its angular size increases, its brightness peaks, its features become more resolvable. Every major telescope on Earth will be pointed toward Virgo, where the object currently resides. The Hubble Space Telescope and James Webb Space Telescope will add their unparalleled capabilities. Ground-based observatories from Chile to Hawaii to Spain will track its motion night after night. What will they see? This is the question that haunts every astronomer who has studied the anomalies. Will the jets persist? Will new structures emerge? Will the trajectory continue along the predicted path? Or will additional non-gravitational acceleration reveal itself? Will spectroscopic analysis of the expelled material show compositions consistent with natural ice sublimation, or something else entirely? The data will come, the interpretations will follow, and one way or another, we will know more than we know today. But knowing more is not the same as knowing enough. 3I Atlas has maintained its ambiguity through months of observation. It has shown us anomalies, but not proof. Unusual behaviour, but not unambiguous signatures. Enough to question, but not enough to conclude. This pattern may continue. The object may pass closest approach looking exactly as it has looked for months. Active and strange, but explicable if you squint hard enough at the models. The mainstream narrative may hold. Scientists may publish papers explaining away the discrepancies. The public may lose interest as the object fades into the outer darkness. And we may never know whether we witnessed something extraordinary or merely something unusual. This outcome is perhaps the most likely. Cosmic mysteries rarely resolve themselves cleanly. The universe does not provide satisfying conclusions on human timescales. Ambiguity persists, but there is another possibility. The coming weeks might bring clarity. December 19th might be the moment when 3I Atlas reveals itself, not through transmission or contact, but through behaviour that cannot be dismissed. A sudden course change would be definitive. Natural objects do not alter their trajectories in deep space. Outgassing produces gradual, predictable deviations, not sharp turns. If 3I Atlas changes direction by even a fraction of a degree in ways not attributable to known forces, we will have our answer. The release of subsidiary objects would be equally conclusive. If telescopes detect multiple sources of light separating from the main body, if trajectory analysis shows objects departing on independent paths, the natural comet hypothesis collapses. Comets fragment, yes, but the fragments follow gravitationally determined trajectories. Deployed objects do not. Electromagnetic emissions in non-natural frequencies would remove all doubt. Radio signals at wavelengths not produced by physical processes, modulated transmissions carrying information. Any communication attempt, even one we cannot decode, would transform our understanding of the universe and our place within it. These scenarios are improbable, but not impossible. The anomalies we have already documented suggest that improbable is exactly what we should expect from 3I Atlas. The countdown ticks. Each day brings the object closer. Each night provides another opportunity for discovery. And somewhere in those approaching hours, the answer might be waiting, hidden in data we have not yet collected, encoded in observations we have not yet made, suspended in the ambiguous space between Comet and something more. What should we do in these final weeks of uncertainty? First, pay attention. Do not let the comfortable narrative of natural phenomena lull you into inattention. 3I Atlas deserves scrutiny. The anomalies deserve explanation. The questions deserve answers. Second, demand transparency. Whatever governments and institutions know, we should know. Whatever observations are made, they should be shared. The stakes are too high for information hoarding. Third, maintain perspective. Even if 3i Atlas is exactly what the mainstream claims, a natural comet from interstellar space, it remains scientifically extraordinary. Only the third such object ever detected, a visitor from another stellar system carrying information about planetary formation processes billions of years ago and light years away. Wonder is appropriate regardless of whether that wonder is tinged with concern. Fourth, prepare for continued uncertainty. The most likely outcome is that December 19th comes and goes without resolution. The object passes closest approach, begins its long journey toward Jupiter, and leaves us with questions we cannot answer. This is not failure. This is the nature of exploring the unknown. Certainty is rare. Progress is incremental. Mysteries endure. I have taken you through the evidence as I understand it. The trajectory precision that defies random chance. The jets that challenge cometary physics. The mass ejection that does not add up. The perihelion maneuver hidden behind the sun. The Jupiter rendezvous at the edge of gravitational possibility. Each anomaly has potential natural explanations. Each could be the result of unusual but ultimately ordinary processes. The scientific establishment is not wrong to demand rigorous proof before accepting extraordinary conclusions. But the accumulation of anomalies troubles me. Not any single fact, but the pattern. The way each oddity points in the same direction. The way each explanation requires assuming we have been extraordinarily unlucky or extraordinarily ignorant. I do not know what 3i Atlas is. No one does, despite confident pronouncements from various quarters. The data does not yet support certainty in any direction. What I know is that we are witnessing something unprecedented. An object from another star passing through our system, displaying characteristics that do not fit neatly into established categories. This alone should command attention. This alone should provoke wonder. And if it is something more than a comet, if the anomalies reflect intent rather than accident, if we are glimpsing the first confirmed evidence of technological intelligence beyond Earth, then these 20 days matter more than any 20 days in human history. The countdown to December 19th is not just an astronomical event, it is a threshold. Whatever crosses that threshold, comet or craft, natural phenomenon or artificial construct, we will be different for having witnessed it. The stars are not empty. We have always suspected this, dreamed this, feared this. Now something travels among them, and for a brief window it has come close enough to study. Look up, watch, wonder, and remember this moment, whatever it brings. 3i Atlas approaches, 20 days until closest approach. The universe is watching us watch it, and somewhere in the darkness between stars, the answer to our oldest question might finally be taking shape. Thank you for joining me through this exploration. I know it has been long, and I know the territory has sometimes been unsettling. But these are questions worth asking, mysteries worth contemplating, possibilities worth considering. If you found value in this journey, please take a moment to like this video and share it with others who might appreciate it. Subscribe if you have not already, and activate notifications so you know when new content arrives. These topics evolve rapidly, and I promise to keep you informed as developments warrant. This channel exists because of you. Your curiosity, your engagement, your willingness to explore difficult questions alongside me. I am grateful for every view, every comment, every subscription. As always, I want to remind you that what I've presented is analysis and speculation based on available evidence. I am not claiming definitive knowledge of extraterrestrial intelligence. I am presenting anomalies that deserve consideration and interpretations that deserve debate. Science advances through questioning, and questioning is what we have done together tonight. Whatever 3i Atlas turns out to be, the cosmos remains vast, ancient, and full of mysteries. Our species has barely begun to explore it. Every new observation, every new discovery, every new question brings us closer to understanding our place in the grand architecture of existence. Look up at the night sky when you have a moment. Find Virgo in the eastern morning hours, somewhere in that region of stars too faint for naked eye observation but brilliantly present to our instruments. 3i Atlas continues its passage. A visitor from the dark, a messenger or a comet, a beginning or an ending, or simply a moment in the eternal flow of cosmic time that happened to intersect with our brief presence on this small blue world. Good night, wherever you are, and keep watching the skies.